Fast track for thermochemistry. First, we have the system, which is what you are measuring, and the surroundings, which is everything else. Energy can flow to and from the system and surroundings. The change in energy is the sum of heat and work. An open system is when matter and energy can move in and out of a system, closed if just energy, and isolated if neither. It can also be described as exothermic, the release of heat, or endothermic, the intake of heat. Energy is a state function, meaning you should only care about the starting and ending states and not how it got there. However, heat and work are pathway dependent. Enthalpy is also a state function, where enthalpy change is the sum of the change in energy and the product of the system's pressure and change in volume. However, assuming that the only work present is the pressure-volume work, the enthalpy change of a system at constant pressure is just the heat evolved in the process. Hess's law states that the total enthalpy change of a system for a multi-step reaction is the sum of the enthalpy change of the elementary reactions. This can be simplified to the enthalpy change of a reaction is the difference of the enthalpy change of the reactants from the enthalpy change of the products. Enthalpy is an extensive property, meaning the more stuff there is, the higher the number becomes. If you reverse the reaction, the sign will flip, and the state of the substance affects the enthalpy change. You can get the change in enthalpy with calorimetry, which is the measure of heat flow. Here we use something called a calorimeter, which can either be constant pressure or constant volume. Heat evolved is equal to the product of the specific heat of the substance, the mass in grams of the substance, and the change in absolute temperature. Something to remember is that a calorie is the amount of heat absorbed to increase the absolute temperature of 1 gram of pure water by 1 Kelvin, which is 4.184 joules, or joules per gram Kelvin for the specific heat of water. There are 4 types of enthalpy change: vaporization when liquid turns to gas, fusion when solid turns to liquid, and combustion when an organic compound becomes CO2, CO, or elementary carbon, and water. The fourth is the enthalpy of formation, which is the enthalpy change when 1 mole of a substance is formed from its constituent elements. At standard state, which is 1 atmosphere of pressure and 298 Kelvin, the standard enthalpy of formation for elementary substances is 0 kilojoules per mole. Standard state is denoted by a superscript circle. You can add 2 chemical equations together to get the enthalpy change of the new equation. The equation to get the standard enthalpy change of a reaction is the sum of the enthalpies of formation of the products multiplied by their coefficients minus the sum of the enthalpies of formation of the reactants multiplied by their coefficients. Finally, we have bond enthalpies, which is the amount of energy required to break bonds. The enthalpy change of a reaction is the difference of the bond enthalpies of bonds formed from the bond enthalpies of bonds broken.